if you have a pasture right now that has 44 cows in it, and right at the present time, they produce 112 gallons of milk per cow for the month. Every single month, they produce 112 gallons of milk. So you could say something like this, that for every let's say this, for every cow, for every single cow added to the pasture, it will decrease the milk production by 8 gallons per cow. What would be the ideal number of cows that you'd want to put in this pasture? Right now you have 44 cows and they produce 112 gallons of milk a month.
Per cow, right?
Yeah, each cow produces on the average 112 gallons of milk a month. For every cow that you put out there extra, you decrease the milk production per cow by 8 gallons per cow.
So there are 24 cows, right?
44.
44
How
cows.
do you decrease milk if you added cows?
Because you're losing
less
other cows.
Yeah.
Instead of that one cow, now you're depending on just that one cow, that one cow.
Now that problem should be a problem if you know how to work, because we've already worked several problems like this.
Decrease the milk by what? Decrease the milk by how many gallons for every cow?
8.
How would you go about working that problem?
You have to find the maximum, like, you have to find the maximum point.
Okay. Anybody getting pretty close to the answer, or?
Are you trying to figure out how many cows are needed? Just on this pasture. Needed for what?
To get the maximum amount of gallons per month.
So
I got the maximum amount of what it currently is.
It's my,
I got the maximum, if you add another cow to it, then you gotta multiply 45 times 112, which gives you 400, or 4,000 and, or 5,000 and some odd numbers, and then you gotta minus 360 because you gotta minus, 8 gallons per cow. So if you multiply that number by how many cows there is, and that gives you 360. And you subtract that, and that's less than what you started out with, which was 4,928.
you got less by that?
Yeah.
If you add one more cow, you get less cat,
Yeah,
less.
that's what I got.
Just by adding one cow, then you get 4,680.
Yeah.
But you can probably.
Is that less than what you started with?
Yeah, but I guess you could add more cows. I don't know how to do it. So.
Okay, let's do this. For every cow, you lose 4 gallons of milk per cow. For every cow that you add, you lose 4 gallons of milk.
Oh, hang on. It's only, you only subtract for the cows that you, like the sum of the number of the cows that you have, or only the cows that you add? Like, do we subtract?
Every cow loses 4 gallons of milk. The production drops by 4 gallons of milk per cow. Everybody got it set up correct way? Set up, set up. You got your set up? Where'd you get that? Oh, but you're not working on that problem. That's a different problem?
Yeah.
Okay, well, all right,
This is that.
let's,
Let me get it for a second.
just go to that website and crank up the practice test or whatever. There.
Yeah.
Chapter 3, I guess, or whatever.
You mean take the post test?
Do what?
Chapter 2 post test?
Chapter, look at chapter 3, I guess, so. Or you go into chapter 2 if you want to. Whatever chapter you want to go to. Go into chapter 2.
What's our next test over? Is it chapter 2 or chapter 3?
Do what?
What's our next test over? Is it chapter 2 or chapter 3?
Chapter 2.
Three tests for chapter 2.
Anybody get the one about the cows or whatever? What is that?
Hold on.
They get the one about the cows?
Did I get a ballpark number?
Did you get it?
I got the same outcome.
Of what?
I mean, I don't know how to set it up the right way, but the way I did it, I still got the same outcome, even with -4 per.
So now we have to.
Because what I did was I multiplied 44, multiplied the beginning 44 cows times, 112 gallons. So that equals out 4,928 per month. And then if you add one more cow in, then that's gonna give you 4,000 or 5,000, some strange number. And then you got a minus 180 because 4 times 100 and 4 times 45 is 100. And then if you minus that, it comes out to 4,860, which is less than.
Even added one extra cow, right? Huh. Let's see. It's 44 times 120.
44 times 112 is 492.
44 times 120 is 5,280.
4,900. And then 45 times 112, 5,040. And then I take 4, multiply that by how many cows there were, 45, that's minus 80. So you gotta take minus 180. And you gotta take 5,040, you gotta subtract by 180. It comes out to
2860.
Yes, sir. And that's below what you started with.
Yeah, try to make one of these problems up, not doing really good, so you don't add another cow, do you?
Mm.
Do you decrease any cows? If you could decrease cows?
No, it was a guy.
If you decrease cows, it would add up, say, 4 gallons of milk?
That work.
But that may
You could do that,
work,
you could
but
just
how would you
decrease
go
all the
about doing
cows to 1. If you could do it that way, you could just get rid of all the cows except for 1, if it would decrease or increase the milk, but that's not how cows work.
But it only increases by 4 gallons.
Yeah.
So you gotta find if it's worth taking away 112 gallons to add on that 4 gallons to each remaining cow.
But regardless, how you set it up,
What was 44 times 112?
4,928.
Yeah, we'd have to,
that's one thing.
you'd have to change that from 4 gallons to say possibly, 2. If each cow lost 2 gallons of milk, and that may work out. The way you would set this up, everybody, is the production would be equal to 44 plus X times 112 minus 2x. If you lost just 2 gallons per extra cow you added. Do this multiplication and then find the vertex.
We've done that.
And then you got your answer right there. It may be a decimal. If it is, you go up to the low, drop down the lower cow, yes.
We did that, and ended up with a negative X value
It's what?
for the vertex. We did that, and
Yeah.
ended up with a negative X value for the vertex.
Even with the 2 cows?
Well, you did 4.
4, yeah, 4, 4 won't work.
Well,
Making it up
okay.
as 4, you'll lose, you can't have an extra cow.
Yeah. Okay.
So that's why I changed it back to 2 gallons. That should work, and maybe a couple of cows you could add. So, I think this is how much here, 40, that was what, 40 what, 49, 12 you said?
Oh, yeah, 4,928.
This time this is minus, that's still gonna be minus 88, plus 112x, minus 2x squared. This is gonna be minus 2x squared, 88, that's plus 24x, plus 4928. Everybody see that now? That's gonna make this a minus 24 divided by a what? A minus 8, which is what? You add 3 extra cows and that's all. You can only add 3 extra cows.
Why is it -8?
No, we
and not
reduced-
-4?
We reduced that.
Oh, it should be minus 4, I'm sorry.
Yeah, they were-
6 extra cows, I'm sorry.
Yeah.
I can't do the arithmetic. I'm having trouble, yes.
That gives you 2,500 gallons of milk.
2,500 gallons?
Yep.
So- Give me how much?
2,500.
I don't even get how, what do you do after that?
Oh, no, we reduced it. It's gonna be.
Oh, yeah, that's not right.
Where did you get 24 from?
Should be 5,000.
How much?
Should be 5,000, Chris.
5,000 gallons.
Yeah, exactly.
Yeah, should be about 5,000, it's gotta be more than 4928.
We reduced the equation from the negative 2x squared plus 24x plus 4,928. We reduced that to negative x squared plus 12x plus 2,464. That's why ours came out to 2,500 instead of 500.
Oh, you using, instead of 2928?
Yeah, he simplified. But I have a question, where did you get that, negative 24 divided by 4?
I just made that up.
Okay. Okay. Okay.
Look at his face.
I hope our church doesn't have little problems on all the
My
time.
answer's 5,292.
These are different.
files for different tabs. Yeah. And I just sit there and flip through them, or different windows, so then I just keep going back and forth. Once I got it, I go take a quiz, and usually get
Taking the post test?
well, I can't take the post test, so they don't come up, but they have a quiz for each section.
Yeah.
The sheet, they appraise on it,
Yeah.
but it's just practice.
That's quiz that can translate pretty easily to the test.
Oh, yeah. It's, dude, it's almost the same as that.
He takes questions from his lesson.
I mean, that's why I'm verbatim.
Well, like, you might change the value, but I mean,
It's the same exact question. It's like there, like when we took the drawing test, and we had a question about the track, and like how many square foot the track is, dude, that problem's like 3 or 4 times mathematical. But I'm like, there's log on the computer. You can open it. No, you can open it. You can open it. You can open it up. All I did was Google everything.
If everybody will go to chapter 2, this is under the, chapter 2 quizzes under course documents. And has anybody opened up section 4 quiz yet? You already opened up section 4 quiz?
Mhm.
Will it let you go back to it, or you already completed it?
It'll let me go back.
I'm gonna go back to it, and let me go back to Castle Preview. Let me go back to lessons, course documents, chapter 2 quizzes. And that was, I said it was, what, a section 4 quiz, wasn't it? Let me go make a quick change real quick. Let's do, let me go back to this real quickly. It should, I'm gonna go into it as a student, course documents, chapter 2 quizzes, chapter 2, section 4 quiz. Is everybody there?
Yep.
And you should see it written as all in one picture, right?
No.
All the questions should come out.
Question at a time. The
Oh,
first
now it
test
is, yeah.
all in one.
And all the questions come up at one time.
Yes.
Go back to your home page or whatever, and then click on it again, and all your questions will come up. They should all come up in the same order. Everybody there?
Wait.
Everybody's there. Question 1 says what?
Study the discriminant.
Work that problem for me real quickly and tell me what the answer should be. None of the other machines working? Machines not working? Machines not working? You can go get on a machine where you won't have to share. Let me know when you get the correct answer for number 1.
Can we just say it, or?
I don't have my calculator with me. How many of you understand what they're asking you to do?
Just find out, what the determinant is, and if it's a negative number, then it's 2
Yeah.
non-real numbers, and if it's a positive number, then it's 2 real solutions, and then if it's 0, then 1 real solution.
What?
1 real solution if it's 0.
It's that last one?
If it's 0, then it's 1 real solution. There's 2.
Always 2.
But it's the same one. But it's just twice.
It is
Yeah,
two
it's a
rational.
repeater.
No, it's 2 non-real solutions.
We'll make it error.
Isn't it? Did y'all get 800? Negative 800?
Negative 800.
I might be looking at.
Okay, does everybody understand question number 1? You don't understand question number 1? What is it that you don't understand?
The question?
Do you not understand what it's saying, what it's asking you?
I don't know how you figure that out.
You know how to figure it out?
No, I don't know how to figure it out.
Okay, listen up everybody. If you don't know what that's saying, you have to go back and remember what we did just a few days ago. And I wrote this up on the board, and I think there's a lot of stuff going on in the room, and that's why it's not. We do this. We do b squared minus 4ac. That's all you have to check. That's all you have to check is the discriminant. We did this the other day. And in this case, if you look at that problem,
You get squared root
b
800.
is 20, so 20 squared is 400. Minus 4 times 4 times, I think it's 4. Yeah, times what? 25.
Yeah, so it's
Now, somebody check this out for me.
I got negative 800.
This is 400, and that's what? That's 100,
400.
and that's 4, that's what?
Negative 400.
Now, what happens, what does it say? What does that mean when you get a 0 under there? It means this, whatever minus b plus or minus 0 divided by 2. I mean, that's sort of what it means. And if b is 8, then you got what? Minus 8 plus 0 divided by 2. And you got minus 8 minus 0 divided by 2.
That's the same answer. There's one
Now,
solution.
it's going to tell you one real solution, but that one real solution is a repeater. That is a minus 4 solution. That's one rational solution. But that one rational solution is minus 4, and minus 4 occurs twice. That's why it says they only call it one rational solution.
So on the test, are you looking for 1 or 2?
It's, what now?
Like, I understand that it is two, but on the test, is the.
Yeah, that would, yeah, it would only say that there's one would be the correct answer.
Okay.
It would only tell you that it'd be one, because if this turned out to be a number, then you have to look for what? Two either rational solutions or two irrational solutions. If this turned out to be a negative number, then you know it's two imaginary or two non-real solutions. Does that am I making sense?
Mm-hmm.
Ms. Pippin, does that make sense now? Do you understand what they're asking you for?
Yes.
Anybody else? Does everybody else understand?
So number 2 is two rational solutions, right?
I don't know the answers because I'm looking at the student version. That's the only way I can look at it to see the question and everything.
Yep.
Is it two rational solutions or two imaginary solutions, two non-real solutions? Did you get a negative on the discriminant? Or was the
No,
discriminant
it's
negative?
positive. It's positive.
It was positive?
Yeah.
So your choices now is what? Two rational solutions or two irrational solutions?
Two rational because it's 25, and so it's 5.
And negative 5.
What's the answers?
5 and negative 5.
Is the answer? Yeah.
Yeah.
Two rational?
Yeah.
How would you know if you got two irrational solutions?
You wouldn't have a repeating, or
Huh?
you wouldn't have a decimal.
Yeah,
Or-
What?
Or like you would just have a bunch of numbers, like going on, not repeating or anything.
Well, what if it truncated before it started repeating?
I don't know. That's a good question.
You'd have to look at it and see if you could break it down to say this, for example, say if it's,
So irrational numbers are something you can't make a
like
ratio
that,
out?
for example. You can write this as what? 45 times 7, right? This would become outside like this, but look at this, folks. See, 7 is a what? It's a prime number. That's an irrational number. The square root of 7 is irrational. Square root of 11, square root of 5, square root of 3, square root of 2. Is the square root of 12 irrational? Yes, because it's 4 times the square root of 3. It's actually 2 times the square root of 3. And you know the square root of 3 is what? Irrational.
And then if it's non-real, there would be a negative under the discriminant?
Yeah, it'd be a negative on the square root if it's a non-real solution. It's called imaginary solutions. That first question, the answer should be and should have been written like this. the solution set is of even multiplicity. The solution set is of even multiplicity. That would mean what? That there's two of the same numbers. I think we got what for the very first one? What was the first answer? I can't remember. It was 5?
Oh, it was 0. 0 under the discriminant.
Yeah, but what was the number?
What do you mean?
Well, the solution would be what? Even multiplicity.
Yeah.
It'd be the same there was the same answer repeated. They got just one solution. That quadratic has two solutions. And the two solutions may be the same number, so they need to identify that as by saying what? Even multiplicity solution. I don't know why they didn't say that. Because that's certainly super important to know that. If they say one real solution, I take that to mean there's only one number that's the solution. But it's actually one number that's even multiplicity. It means what? That one number occurs twice. They need to make that clear, and they don't. I sort of fault whoever made up these exams for that. That's not. Looks to me like they go through quite a number there. Number 4. Number 4.
Four's got fractions, you know nobody can do that.
You what?
So number 4's got fractions, you know nobody can do that.
Oh gosh. Oh heck. Does everybody know how to do number 4?
We found the birthday.
Sure he does, right? Good morning.
Number
No,
4.
You find the radius of the semicircle. And then you multiply that
Number
by
4.
2, and that becomes your. So you gotta find.
Number
your
4.
radius.
Number 4.
They were trying to do it.
Number 4. Number 4. Everybody working on number 4?
Yep.
We're working out. I was giving you my answer.
Everybody working on 4? You're not working on anything.
I can't get on. It doesn't want me to log on.
It won't let you log on?
I'm not saying, but it doesn't. I put it in, it still doesn't work.
It doesn't let you log on? Have you not, when's the last time you logged on?
And they said that some people's got changed back to their birth date.
I tried that too,
That's
but
what mine said.
Do you use your 6-digit or 8-digit birthday?
try your 6-digit.
You haven't been able to log on at home either?
Yeah, but we don't have to log on using them. Yeah, we don't have to get
You
on
don't have to go
this.
through that.
Oh, you mean logging on to the school
Yeah,
computer?
I can't log on. Try your 6-digit. Oh my God, how many times does this
How you
log
been
in?
logging on it here? You been logging on it here before?
This thing always makes me.
Did you log, were you able to log on, Tuesday?
No, she just figured it out.
Huh?
She just. I was doing my wrong birthday, like I was doing 1993 instead of which night it was.
Yeah, for real, though. Somebody can hold it. That's what I'm saying.
Everybody can't be born until 70.
And that's the thing, it always happens. They changed.
Mm.
I don't know why. Fucking stupid, it's stupid, one little thing.
Right?
No, I have a question. So, because it's a semicircle.
No. Ow!
Why would that?
They know
work?
semicircle.
Why would that work?
Ah!
No,
Ah.
no, look at it.
Ah.
Shut up.
How would that not work? Why would that not work?
No, it like that. Is that a semicircle? That pumpkin could go like that. Is that a semicircle? Alright. So Jimmy tried to do no semicircle. Hey, you would have said, it would have said, pumpkin travel with a semicircle. They're not gonna make it that easy.
Should've made it.
They're gonna make it easier than that.
Should've.
Easier than that. You're working it the hard way, trying to do it with a semicircle. Everybody get it? You get it?
No, I don't.
Look, this is the height, right?
Mhm.
You're just gonna try to find out when this is what?
I think I got it.
0. If that's the height.
Oh, okay.
Oh, Does that make it easy?
Yes.
Yes.
Will you give me a hint? Will you give me a hint?
Give you a hint? Look at that. Where's your pumpkin? I can't see it.
Right here.
Look at that. You see this? You know what that stands for?
It's over X.
What's this stand for right there?
Height.
The height. You wanna know when this pumpkin is on the ground.
Oh, hello.
What do you mean? Oh.
Is this right?
Of course.
I'm sorry.
When is he gonna go in this bucket? When he's on the ground, right?
Mm-hmm.
So, is he on the ground back here? Yep. When is he on the ground again? How many times is he gonna be on the ground?
Twice.
Why? Because that's a square.
Oh, yeah.
Oh, yeah?
Oh.
Is that right?
What's right? Oh, I don't know the answer.
You ain't know that.
Y'all look at me like I'm supposed to know the answer or something. What's the guess? Hello?
Oh, this is so easy.
Oh, you wanna know, when is the height there? So what is it on the ground? When you hit the bucket, it's on the ground. So you just make this 0. It's off red.
Yeah, that's exactly what.
Oh, that's good. Try to speak. Your book, no, what's your book in the way here? Yeah, fine, you got all kind of stuff in the way. Y'all hurry, work that problem, come on, hurry. Get this off here. Oh, okay, that's the other problem. When, that's the height, right? When is this 0? Yeah, it's a simple problem, it is so simple now. It's all off the log simple. Did you see that working?
No, I just got here.
Okay, when is this 0? Set this to 0. It's all it's just so simple.
Oh.
Maybe no.
Yeah, is it 100 or 160?
Holy cow, everybody.
Well, look at there.
So y'all got 0?
I have to go back over here. This is h of x. What is it? Minus 7 over what?
640.
What is this number
640.
here?
640.
640?
Yeah.
And then what goes here?
7 over 4. X.
Folks, this can't be any simpler than this. Y'all look up here a second. Hell, what did the pumpkin do? The pumpkin hit the ground. So you want to know, when is this what? 0. This is 0 when you can factor out this. How you make a 7? Oh, like that? Oh, I mean a 6.
Oh, what do you mean, oh?
Does everybody see that? So it's very simple. When x is 0, the pumpkin's on the ground. So that was gone. Let's stop, everybody. I'm up here talking. When x is 0, the pumpkin's on the ground. And guess? Now you saw this for x. This is 6x is equal to 7/4 times 640. I don't know what that is, but somebody multiply this out for me. That becomes 6x equals to, how much is that? 7 times 640 divided by 4. Quickly, would you calculate it? Somebody do that multiplication. 7 times 640 divided by 4.
1120. 1120.
1120. Divide that by 6.
Why?
X is equal to what?
Supposed to divide by 7.
Supposed to divide by?
7.
It's 160.
160, what?
It's 7 over 6.
Oh, this is 7?
Yes, sir.
Who did that?
Divide by 7. I got, what, can I get some credit on here?
Yeah.
1120 divided by 7 is how much?
160. 160.
So guess what the answer is?
Look at there.
160 whatever, feet or meters or whatever. Hell, I don't know what it's measured in.
So we're not,
Feet.
Now, let me ask you a question. Was that an easy problem? That's the same kind of problem we've been working where we did what? Where we had the rock going like this, remember? I mean, isn't this the same thing as the rock being thrown up? Is what? It is shaped like this, right? Any questions about that? Nobody got it worked?
I had it worked.
Where's your semicircle at?
Hey, I got it.
Ah, you didn't need it. I'm about no semicircle.
Not with the semicircle.
That's no semicircle.
Hey, I made 100 on the quiz, you can come look at it. So, I mean,
You go to hell for lying, same as Stephen.
hey,
And look, you don't get this thing may do that. That's not a semicircle. That makes sense? I mean, the pumpkin could do that. You don't know. It just said the pumpkin being shot in the air. If you tried to work that by a semicircular thing, you'd be in a fix.
Is there any way to figure out how much?
This one?
Is there any way to figure out how much force the cannon needs to put on the pumpkin to determine?
No.
No.
There is something you should get.
Let me ask you a question. Do you see the 7 force? That would have to be the actual vertical motion of the pumpkin. First of all, let me show you something a second. I'm going to leave it sort of like this, okay? I'm going to leave it like this to my What? These people bark anymore. Yo, give me 1 second. When you have something being fired like this pumpkin or whatever, and it travels like this, and I've exaggerated its path. Go hush. I've exaggerated its path. Well, the only way that this can happen is this pumpkin, for example, has to have a what? A motion like this. And doing that is also has what? A horizontal motion, right? And it also has a what? a vertical motion. In other words, if you can only measure its upward, if you can only measure its upward straight up speed, then what's making this pumpkin go this direction is the fact that you have a force this direction and you have a force in an upward direction. Now what you have to remember is, it takes a little bit of trigonometry to realize that this force right here is this value. And folks, this value happens to be its initial velocity. That's its initial velocity. Now if you're shooting something across like this, it has two components. It has a vertical component, it has a what? A horizontal component. And y'all listen to what I'm telling you, damn it. Its vertical component and its horizontal component resultant is here. Something in between these two. And that's where this thing comes from. It actually has a horizontal motion. It has a vertical motion. But when you start discussing this vertical motion, you have to take into consideration that it's being pulled back this way with what? By a gravitational pull. So, and I'm not here to try to teach you a trigonometry class, but if everybody had a trigonometry class, you could see very easily that this distance right here, that distance that pumpkin travels is called the range. How far down range does it go? Well, it's actually going to be this. That's, you can't change that, folks. That is cut in stone. That is cut in stone. That range that this pumpkin is going to travel is going to depend on two things. That's the initial velocity and the angle that you point the pumpkin at. Let me go back and remind you of something that's important to you after you leave this school. And you never know when you might be asked about it. If you're firing something like that, that's something, if you keep the same initial velocity, then it'll land right there. And that is as far as it will go, provided that this angle is 45 degrees. Provided the angle is 45 degrees, and the reason why is because what in the world is 2 times 45? 90. And what is the sine of 90 degrees? You can take your calculators right now and punch sine of 90. And you better get back 1. That is the biggest that number will ever be. It will never, ever, ever be larger than 1. So when this is 45, then this becomes sine of 90 degrees, which is 1. If you happen to go 10 degrees above this, which will make it 55 degrees, then the pumpkin or whatever you're firing is going to do this number. And if you go 10 degrees below that, which is 35 degrees, and you fire it, it's going to do that. Now, you use this quite a bit in the Army because you have to know this situation, because there may be times in which you would want to do what? When do you think you'd want to do this versus this? Well, you would do the 35-degree one if you want your projectile to reach that target and you don't give a damn what you hit as fast as you can. The other method of lobbing it in like this is when you were trying to do what? You've got what they call a time fuse. You set a time fuse on the projectile. And when that projectile gets a certain distance from the ground, it explodes and you do more collateral damage, and you can wipe out, if you've got a large company of troops or whatever that you're trying to rid yourself of, you can fire the projectile with a time round, and you set the round. You actually set the time. You got a timing wrench that you actually set it with, and we used to lob them over and up high and do that number. So, anybody been in the Army? Nobody? You've been in the Army, you've been in the Army, haven't you? They lob those rounds like that sometimes, and
Well, yeah, they'll lob them up 5 at a time and they'll all impact at the same time, but they'll do it at different angles.
yeah, they'll do a volley fire, and just, that's why I can't hear now, so, out of my left ear, so. But you sit there and just firing 24 hours, ooh, ooh, ooh. They didn't give us earplugs either. You didn't have time to put them in anyway, so. But, does that make sense to everybody where I did this? At 45 degrees, it's gonna go its maximum distance. Anything less than 45 or greater than 45, then this number right here, see this number? It will be a smaller number than 1. So when this is smaller than 1, then this is going to change the range to some shorter distance, right? The only way you can compensate for that is do what? You can increase your initial velocity by putting more powder bags in the projectile, in the round. You got up to 10 powder bags. In some cases, you can put different amounts of powder. They'd say, okay, 7 loads means what? Drop 7 bags of powder in there. What were we doing? We were shooting pumpkins, right?
Yeah. I think we could.
You know, go back and look at some of those example problems. Because I did assign them, like say, I also said they won't count for grade, because I would have
Somebody had just said that one time, it really keeps
60 grades listed for you. That'd be horrible, man. Well, I'd have 60 grades for some of them, and I'd probably have 5 grades for some of them. So,
See, hold on, hold on.